You just tapped a heart on someone's photo. That tiny instant red heart triggered something that traveled through your phone's antenna, jumped into a cell tower, hopped across fiber optic cables under the ocean, landed in a data center halfway across the world, ran some code, wrote to the database, and sent an answer all the way back in under 200 milliseconds. And every app does this. Every button, every scroll, every notification. It's all the same 5 step dance, repeated billions of times a second across the internet. This dance has a name, the client server model. In the next 10 minutes, you will understand exactly what's happening every time your phone talks to a computer somewhere else in the world. We are starting module 2. The building blocks. This is the first one. Let's get into it. The client server model is the simplest way to describe how almost every app you have ever used works. Two players. One is the client, whatever the user is holding, your phone, your browser, the app on your watch. The client is the site that asks for things. The other player is the server, a computer running somewhere else, usually in a data center. The server's job is to answer the asks. It listens, it thinks, it hits the database, it comes back with whatever the client wanted. Between them is a request. The request is a small message that travels from client to server, saying exactly what the client wants. The server reads it, does whatever needs doing, and send back a response, another message with the answer. That's it. Two players, two messages, client asks, server answers, and done. Now you might say, what about the real-time apps? What about WebSocket connections? Fair questions. We will touch on these later. But the vast majority of the internet, every API, every website, every mobile backend is just this simple dance. Master the request response cycle and you have understood 80% of how the modern internet works. Stick this in your brain forever. Every interaction on the internet is a client asking a server for something and the server sending an answer back. That's the whole game. Here's the analogy that makes this whole thing click forever. A request is a letter, a literal physical letter sent through the mail. Think about what a letter has. First, an address on the envelope. You can't just mail a letter to somewhere. You need a specific house at a specific street in a specific city. That's the URL, the address on the server you are talking to. Second, the type of letter matters. In this, a postcard saying hi, a registered package needing a signature, an invoice. The type tells the recipient how to handle it. That's the HTTP method. Get means I would like to read something. Post means I am sending you something new. Delete means please throw this out. Third, the notes on the envelope. Your return address, the postage class, fragile, this side up. These are the headers, extra info that helps the server process your request, like who you are and what format you expect back. And finally, what's inside the envelope? The actual content. That's the body, the data you are sending. The server reads the address, opens the envelope, look at the type and notes, read the content, does whatever needs doing and write back a reply later with its own address, type, headers and contents. That's the entire protocol. A pen pal system running a billion times per second between phones and computers. There are 3 reasons every engineer must understand the client-server model in their bones. Reason 1. Interviews. Every system design interview starts with this. Walk me through what happens when a user types a URL into their browser. If you can't describe the request and the response in simple language, the rest of the interview gets harder. Reason 2. Debugging. The most common question at every job you will ever have is why isn't this working? 90% of the time the answer lives somewhere in the request response cycle. Did the request actually leave the phone? Did the server receive it? Did it return what you expected? If you can't reason about each step, you will waste hours guessing. Reason 3. Everything else built on this: cache, load balancer, CDNs, queue. Every component we will learn for the rest of this course sits somewhere in the request response path. You can't understand where they go without first understanding the path itself. Here's where we are going, the full picture. On the left, your phone, the client. On the right, a web server running your backend code. Between them, the network, the internet doing the heavy lifting of getting bytes from point A to point B. When you tap that like button, your phone builds a request. A request travels over the network to the server. The server reads it, probably talks to database and send a response back. Your phone updates the heart icon to red and you see it happen. End to end in a couple of 100 milliseconds. Now zoom in. Every request, every single one, no exceptions, has 4 parts. The method, what you want to do: get, to read; post, to create; put, to update; delete, to remove. The verbs of the web, the URL, which resource you want. /user/42 means the user with ID 42. The URL is the address. The headers, meta information, who you are, what format you accept, what device you are using, the labels on the envelope. And the body, the actual data you are sending, usually a JSON object. When you sign up, your name and email go in the body. Now here is what it actually looks like on the wire. 2 envelope, request on the left, response on the right. Look at the request. The top line says post/API/users HTTP 1.1. The method, the path, the protocol version. Below that, headers, host, authorization, content type. At the bottom, the body, a tiny JSON object with the user's name and city. The response mirrors it. Top line, HTTP 1.1, 201. Created. The number 201 is a status code, a 3-digit number that tells you what happened. 200 means OK. 201 means something has created. 404 means not found. 500 means the server crashed. Memorize a handful and you can debug any API without ever asking for help. Then headers, content type, set cookie, and the body, what the server sent back. The whole protocol, the entire foundation of modern web is text, plain readable text. Once you see it this way, the mystery disappears. I want to be honest with you about something most courses won't tell you. The good news is the client-server model is brilliantly simple. 2 players, 2 messages, easy to reason about, easy to scale. You can spin up more servers if traffic grows and the client don't notice or care. This simplicity is why it's powered the internet for 30 years. The bad news, it has a limits. The server only knows about you when you ask. If something changes on the server side, say a friend sent you a message, the server can't just push it to you. You have to ask. That's why your phone polls. It checks every few seconds. Anything new, wasteful. For real-time apps, chat, live trading, collaborative editing, this model breaks down. We have other tools for those: WebSocket, server sent events, push notification. We will cover them later. Just know, when you hear real time, that's the moment client server alone isn't enough. Even from this one video, you can confidently handle 4 of the most common opening interview questions. Question 1. What happens when you type a URL into your browser? The browser becomes a client. It sends an HTTP GET request to the server at that URL. The server reads the request, fetches the page, maybe from a database, and sends back a response. HTML, status code, headers. The browser renders the HTML, that's it. Question 2. What is the difference between GET and POST? GET is for reading. It doesn't change anything on the server and you can repeat it safely. POST is for creating. It sends new data and repeating it creates duplicates. Use GET when you are looking. Use POST when you are sending. Question 3. What does a status code 404 means? The server understood your request but couldn't find what you asked for. Different from 500, which means the server crashed. Different from 401, which means you are not allowed. The first digit tells you the category. 2xx is success, 4xx is a client error, 5xx is a server error. Question 4. Can the server talk to the client without the client asking first? In the basic client-server model, no. The client must initiate. That's the real limitation and it's why we invented WebSocket and push notification. To break that rule when we need real time. That last one will mark you as someone who actually thought about the model, not just memorize it, trust me. Before you go, take 30 seconds to log this into your brain. Takeaway 1. 2 players, 2 messages, the client asks, server answers, every interaction on the internet is some version of this dance. Takeaway 2. Every request has 4 parts: method, URL, headers, body. Every response has same 4 parts plus a status code. It's all just text traveling over the network. Takeaway 3. The client always starts the conversation. The server can't push to the client without help. That's the real limitation and it's why cache, queues and WebSocket exist. In the next video, we will zoom into server itself, what a server actually is, physically and logically, CPU, RAM, disk, network card, why those 4 things determine every design decisions. If this helped you, hit subscribe so you don't miss the next one. The full playlist is in the link below. See you in the next one.